Hi everyone, welcome back. Today we'll be focusing on multiplying and dividing rational numbers. This is a continuation from our multiplying and dividing fractions. The standard we're looking at is 7.ns.A2. Apply and extend previous understanding of multiplication and division of fractions to divide rational numbers. So let's take a look at our rules for multiplying and dividing integers. This will be really useful since we know that integers fall under the category of rational numbers. Now, the rule for multiplying and dividing integers is definitely different than adding and subtracting. So you want to keep that in mind. Look at these three faces that I have represented here. Pretty much what this is saying is if I have two positive numbers, the product or the quotient will also be positive. And we know that because if you multiply 3 times 4, they're both positive. We're going to end up with a positive answer of 12. And if we divide two positive numbers, so 12 divided by 4, it's going to be equal to 3, which is a positive number. What about when we have two negative numbers? So a negative times a negative is a positive number. A negative divided by a negative is a positive number. So pretty much what we can identify here is if I have the same signs, my answer will be positive, right? So if I have positive, positive, my answer is positive. If I have negative, negative, my answer is positive. Now, what about when the signs are different? So if I'm multiplying a positive times a negative, the answer will be negative. And if I'm dividing a negative by a positive, the answer will be negative. So we can actually conclude same signs when multiplying and dividing will give us a positive answer, and different signs when multiplying and dividing will give us a negative answer. Not to be confused with adding and subtracting, right? When we add same signs, we add and keep the signs. So if they're both negative, then our answer will stay negative. Different signs, we subtract, keep the sign of the higher number. Now this is completely different than adding and subtracting. So try your best not to get the two confused, okay? Again, same signs when multiplying and dividing is positive. Different signs when multiplying and dividing will be negative. Now let's take a look at a few examples. So here I just have one of the faces located because we can use this pretty much. So if I have the same signs and I kind of cover these two, I see that it's positive. And if I have the different signs and I cover these two, then I see that my answer would be negative. So let's go ahead and try these examples. So this is telling me that it's a -5 times a -9. So I have same signs. That means my answer will be positive. I'm going to go ahead and just put a plus there to remind myself that my answer will be positive. Let's do the multiplication. 5 times 9 is 45 for a final answer of just 45. Okay. Now let's look at this one. So I have -81 divided by 3. So here I have different signs, so I know my answer will be negative. And I'm just going to go ahead and put that negative down so that I know my final answer will be negative. Now let's go ahead and set up the division. So the process of dividing is just the same. 81 divided by 3. 3 goes into 8 2 times. That's 6 with a remainder of 2. Bring down the 1. 3 into 21 is 7 times with no remainder. So -81 divided by 3 is equal to -27. Let's take a look at -36 divided by -6. So here we have the same signs. My answer will be positive, so I put a plus just to remind myself. Now 36 divided by 6. I know this mentally because I know my square roots, but let's check it out. 3 does not go into 3. I'm sorry, 6 does not go into 3. But it does go into 36 6 times. 6 times 6 is 36. So this means that my final answer is a +6, and I can rewrite it without the plus sign. Now, if you notice, in these two examples, the order does not matter. Doesn't matter if I have positive first and then negative, or negative first and then positive. As long as the signs are different, I'm going to have a negative answer. 12 times 5, let's do the calculation. 5 times 2 is 10. 5 times 1 is 5, plus 1 is 6. So my final answer here is negative 60. So again, same signs, my answer will be positive. Different signs, my answer will be negative. And that's only for when multiplying and dividing. Now let's take a look at some decimals and fractions, and we're going to now apply what we've practiced before as well as our integer rules. So here I have a negative and a positive. So what do you think the answer is going to be? You can absolutely pause here and think it through. So yep, the answer is going to be a negative number. So we can write that negative so that we do not forget. So 3.6 times 2.5. And I don't have to rewrite that negative over here when I'm multiplying because I know that I'm going to add it in at the end with my answer. So 2.5 times 3.6. And let's go ahead and multiply. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. Put in my placeholder. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. So now let's go ahead and add these two numbers. 0 plus 0 is 0. 5 plus 5 is 10. We carry the 1. 7 plus 1 is 8, plus 1 is 9. Okay, so let's go ahead and take a look at our answer. So we have 2.5 times 3.6, okay? Now we have a 900 here, but there's no decimal currently in that answer. But if you remember your rules for multiplying decimals, you remember that we have to count the number of spaces after the decimal point. So here we have 1 space and 2 spaces. So I have to move that many spaces in my answer. So I'm going to move 1, 2, for a final answer of 9.00 or just negative 9. Now let's take a look at the second one. Since we're already working with those decimals, let's continue to do so and take a look at the question below. So the question below says negative 6.3 times negative 0.6. Now taking a look at that, can you already guess how many spaces will be in your final answer? If you said 2, you're absolutely correct. So there's 1 space behind the decimal here and another one here. So whatever our final product is, we will need to move 2 decimal spaces in our answer. Now, what about our sign for our answer? Will it be a positive or will it be a negative? Same signs, will be a positive. Excellent. Now let's go ahead and stack our numbers and multiply. So 6.3 times 0.6. I can write the 0 there if I want for a placeholder, the 0, but it's not going to really change much. 6 times 3 is 18, carry the 1. 6 times 6 is 36, plus 1 is 37. So here I have 378, and I already determined that I needed to move 2 decimal places in my answer. So that's 1, 2. So my final answer here is 3.78. Now I can rewrite this without the positive. So my final answer would just be 3.78. I don't have to write that positive in front of it. Okay. Now let's take a look at our fraction examples. Here we're looking at division. So I have my first fraction, okay, and my second fraction, and both of them happens to be negative. So there I know that my answer will be positive. Now, if you remember the rules that we just explored, we know that when dividing fractions, we have to do keep, change, flip. So we're going to go ahead and keep the first fraction, negative 6 over 5. We're going to change the division sign to multiplication. And then we're going to take the reciprocal of 1/2. I'm not going to do away with my negative. I'm not changing that. I'm going to keep that. but instead of 1 over 2, I'm going to put this as 2 over 1. Now let's go ahead and rewrite this. So I know my answer is going to be positive. And I'm going to rewrite these without the negative sign so that I don't get confused. So 6 over 5 times 2 over 1. 6 times 2 is 12. 5 times 1 is 5. So now I have 12 over 5. Now, based on my last video, I got some feedback that some people are still struggling with converting an improper fraction to a mixed number. So I can do a small video on that if you still need it. Now, in order to convert, I have to divide. So I say 5 goes into 12 2 times. 5 times 2 is 10. So that means there's going to be 2 left over because 12 minus 10 is 2. So my final answer here is a positive 2 2/5. Okay, this is a 5. All right, let's get rid of that and write it better. There we go. Now let's take a look at the third example. I recently posted a video on exponents, so if you struggle with exponent, you can go ahead and take a look at that video. I think it's titled 6.5 Exponents. Now here we're going to multiply negative 1 over 2 times negative 1 over 2 times negative 1 over 2. So exponents represent repeated multiplication. So here, if I have half being raised to the third power, that means I'm going to multiply negative 1/2 by itself 3 times. So that's the reason I wrote negative 1/2 times negative 1/2 times negative 1/2. Okay, and just a reminder that those big dots represent multiplication. Now, the concept is the same here, but I want you to be extra careful. So instead of having 2 terms, we now have 3. So negative times a negative is going to be a positive, but then a positive times a negative is going to end up being negative. So let's actually take a look at this. You guys will see what I mean. So negative 1/2 times negative 1/2 is equal to positive 1 over 4. 1 times 1 is 1, 2 times 2 is 4. Now I'm going to bring down the third negative 1/2. So now I have a negative number. Now I have a positive number and a negative number. So a positive times a negative is going to end up being a negative. That is absolutely correct. 1 times 1 is 1. 4 times 2 is 8. So for a final answer of negative 1 over 8. Okay, and that's because here I have 3 negatives that are being multiplied. So what we can actually conclude from that problem is if I have an odd number of negatives, then my answer will end up being negative. So let's take a look at that concept further. So let's consider these. So negative 2 to the first power will be equal to what number? Yep, it's just going to be a negative 2. Negative 2 to the second power will be equal to what number? Yep, if you said positive 4, that is correct. Negative 2 to the third power will be equal to what number? Did you say negative 8? That's correct. Let's take a look at why. So negative 2 to the third power, let's write it here. Negative 2 to the third power is equal to negative 2 times negative 2 times negative 2. And just like we mentioned in that previous example, negative times a negative will become a positive 4. But then I'm going to multiply it by a negative 2. So that's going to give me a negative 8. So that's where that concept comes from. Okay. Now let's take a look at another example. So I'm going to erase this down here so I have space for my next problem. Now negative 2 to the fourth is negative 2 times negative 2 times negative 2 times negative 2. So now we have 4. So let's try the first two. So negative 2 times negative 2 is a positive 4. And then I'm going to bring down the rest of my work. Positive 4 times a negative 2 is going to be a negative 8. And then I'm going to bring down the rest of my work. Now, negative 8 times a negative 2 is going to be equal to a positive 16. So here we see that negative 2 to the 4th is positive. Now, take a look at that pattern. Can you see something happening? Think about it. I'm going to just delete this here and then fill that in. Okay. Now, if you had to draw an assumption, what do you think negative 2 to the 5th is going to be? Is it going to be positive or is it going to be negative? It's a good place to pause and think about it and then try it on your own. Let's try it. Negative 2 to the 5th is equal to negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is a positive 4. Okay. And then now positive 4 times negative 2 is a negative 8. Then times a positive 2 is going to give us a positive 16. And then we're going to multiply that by a negative 2 for a negative 32. So here we have negative 2 to the 5th is a negative 32. So what can you assume? Is negative 2 to the 6th going to be positive or is it going to continue being negative? Try it on your own and let me know. If you found that negative 2 to the 6th will be positive, then you are absolutely correct. It will be a positive 64. Now let's take a look at the pattern. Negative, positive, negative, positive, negative, positive. All of my odd numbers gave me a negative number. All of my odd exponents gave me a negative number. All of my even exponents gave me a positive number. Okay? So what did we notice as the pattern? Even exponents gave us a positive number, while odd exponents gave us a negative number. Now, based on that, it's not asking you to calculate, it's not asking you to solve it. What is the sign of negative 2 to the 49th? Now you want to ask yourself, is 49 an even number or an odd number? And that will help you answer the question. Now let's take a look at what is the sign of negative 2 to the 49th power. It's not asking you to solve it. What you want to ask yourself is 49 an even number or an odd number? If it's even, will my answer be positive? If it's odd, will my answer be negative? What do you guys think? If you said that the sign for your answer will be a negative, then you are absolutely correct, because the pattern shows us that anytime we have an odd exponent, our final answer is negative. Thank you for watching and have a great day.